research scholar of CSE department. With my fellow mate Asres are going to represent this review paper that is on anomaly detection in time series data. But we have done this review paper on that deep learning on anomaly detection and time series data. The content of our data is introduction, overview of anomaly detection and time series, industrial use cases, conventional method, different anomaly detection methods, deep learning based anomaly detection methods, model selection, some real implementation, conclusion, and references. Our industry became very automated, and the technology also advances in recent days. So as a result, we are having a massive amount of data. A wide range of system continues to generate a massive amount of data. So for that, we did, as it is helping in our life, it's very much helpful for lots of data and improving of data science. We are also having some cons in our technical field that we want to solve for the better bent of the technology. So detecting anomalies using these indicators on time prevent potential accidents and economic losses. So we have to make sure this not happens, so that we are having that problem of anomaly detection that is very current scenario with the researchers, data mining, data science field. We are having the researchers going research on that. So anomaly detection multivariate time series data poses a particular challenge because it requires simultaneous consideration of temporal dependencies and relationship between variables. So now what is anomaly detection? So anomaly detection is the process of finding the outliers. Now we'll talk about what is outliers. Outliers are the data objects that stand out amongst the other data objects in the dataset and do not conform to the normal behavior in the dataset. So basically, it's the anomaly detection is the identification of the data points, events, observations that deviate from the data set's normal behavior pattern. It's that abnormal of this, some anomalous things is some abnormal thing we can say. So it's now one of the main tasks in data mining and quality assurance also. Next, we will coming to the point is the time series data. So time series data is a recent governance topic of the data type, that time series. What is the time series? It obviously comes with the name time. Time is the factor of time series domain. Basically, what we do on the basis of the past, we want to predict the future. So it's widely known example of the time series analysis is not only not only we predict something based on the past thing, we also classify some problem. We are clustering, do some clustering, we do the forecasting and also the anomaly detection. So hand in hand, the anomaly detection and multivariate time series data poses a particular challenges because it requires simultaneous consideration of temporal dependencies and relationship between variables. So what is temporal dependencies? Suppose we are having two jobs and we are completing the jobs J1 and J2, and we are completing the tasks by T1 and T2 times. So the difference between the completion time, that is T1 minus T2, is considered as a temporal distance. Now this temporal distance is said to be temporal distance constraint if it must not be more than some finite value. For example, we have a video and we have a audio clip. Now the different video completion time and audio completion time, there should not be difference between these two completion time more than 160 microsecond, because otherwise the lip sync thing we cannot say that it's the lip sync one, that the first thing, and the video is good, it's the lip synchronization. Suppose we are playing a video of some face, someone is talking, so the synchronization of the lip sync is should be in the simultaneous in the same time. So that would be the job of that temporal dependence, different temporal distance constraints. Now if we can make a age between these two jobs, then it will be considered as a temporal dependency. So similarly, this temporal with there should we have to verify this the temporal dependency and the relationship between between variables. So then only, because that's why then only we can reach our goal. Otherwise, it is a very challenging issue. So recent deep learning based work have made an impressive progress in this field. So now we'll be discussing about the overview of anomaly detection on and time series. So we'll be discussing as they have reviewed on their paper, anomalies and in time series data and properties of time series data. Now what is, suppose we are having the anomalies in the time series data, what type of anomalies we can consider in time series domain? Stealing of credit card, these are the example we can consider: stealing of credit card, medical diagnosis, stock market prediction. Now, stealing of credit card. Suppose you can have a credit card and one unfortunate day your card is stolen. Now, the payment process authority, the company, the like PayPal or some banking organization, they will do keep a track of your all the transaction, the usage pattern. The pattern include the transaction money, the location of the transaction, and so on. So if a credit card is stolen, so yes, they will be there. The company will use the concept of the anomalies to detect. That is there will be a huge difference between the normal procedure. That's why we will be getting sometimes when we do a large amount of transaction, we generally get a call from the our merchant company, the credit card company, sorry, credit card company, that did you have uses your credit card for this transaction, because they are getting some anomalous situation. So the transaction that may take place of after the credit card theft. So there will be, suppose then that you generally don't do at that much of transaction, and also you do not use your card on some severe place where you have not visited earlier. So that was also that anonymous things. Now the medical diagnosis, suppose you visit to the diagnosis center where you want to check your health to the doctor, then for you are having the obesity, so doctor will say you to check the weight. So to time you are following a chart, and you say that a sudden you inform the doctor, suddenly one sudden month you are having gaining the huge weight. So that will you also considered the weight chart. So it will be considered as the anomaly in time series, because time to time you are checking the weight. So Now, in stock market prediction, we all know that is there is a crash news of the stock market. The stock market is not that much good after the war of the Russia and Ukraine. So, if we consider this is the March of month of the March, and if you are doing this in the previous 2 years, cases of the history of the stock market value, then you can easily understand that that thing, because this is considered as an anomaly, because for some reason that things are happened. So if we are considering this, we want to find out the smooth continuing of our time series data and the forecasting. So we have to focus on these anomalies. So anomaly, now we'll be discussing about on the in the paper they have discussed about the different type of anomalies. The different type of anomalies are point anomalies, contextual anomalies, and the collective anomalies. So the point anomalies is it's the most common type. Point anomaly is a data point or a sequence that abruptly deviates from the norm. Suppose this is the point, suppose you are seeing the patterns and suddenly you are getting the hike of the pattern, and then again that is almost normal type of patterns are going to happen. So this is belongs to the point anomaly. Next is coming to the contextual anomaly. Similar to the point anomaly, contextual anomaly represent a data point or the sequence observed over a short time, but does not deviate from the normal range in the same way as predefined the UCL and LCL delimited anomaly, means upper context limit and lower context limit. So this context and individual data instance is anomalous within a context. So basically it is the context based anomaly. Context based means context based of finance, field. So contexts are the almost always very domain specific. The pattern has change in the sequence of patterns and change in here, this part. So this is the contextual anomaly. They have explained in their paper. The, the authors mentioned this part is a contextual anomaly. Then is the collective anomaly. So collective anomaly is something that is if we are considering that is part by part. So individually they are not anomaly, they are not anomalous, but when we consider them together, they will be considered as the anomaly. So it's a sum of the sequence, we can say. So this type of anomaly refers to a set of data points that should be considered on an anomaly because they gradually show a different patterns from normal data over time. Since they are not easily recognizable at once, context over the long term are of particular importance in detecting them. So individually they are not anomaly, but collectively they are. The main idea behind the collective anomaly is that these anomalies is that the data point included in forming the Euclidean means the pattern may not be anonymous when considered individually. So we have to analyze the behavior in a collective manner. Just like that, we are having the similar type of pattern. Now, if we consider up to this, so it will not be considered as the anomaly. But when we are considering all this together, it will be considered the anomalous sequence. So this about the three type of anomalies they have discussed in their paper. Now next is coming to the properties of time series data. Properties of time series data is when we consider the time series data, frequency, continuous cycle, or the noise. All these are comes with the property in the components of the time series. So here we will be discussing the properties, temporality, dimensionality, non-stationarity, and the noise of time series data. So, what is temporality? That is temporal correlation. A time series is generally considered to be a collection of observation indexed in a time order. The data are captured at equal interval, and each successive data point in the series depends on its first value. Hence, there is some implication of the temporal correlation or dependence between each consecutive observation. So, what is temporal correlation? It changes during years, like change in the demograph, geometry, environment, etc. So next is dimensionality. Time series data are generally of two types. That is univariate data. It's very common to all of us. That is univariate data and multivariate data. So what is dimensionality refers? It refers to the number of individual data attributes captured in each observation. According to the dimensionality, time series data is largely divided into univariate and multivariate type. So univariate is the time they describe this. I have already that ordered set of real valued observation where each data point is measured at a specific time, and multivariate is this type of describes an ordered set of multi-dimensional vectors. So anomaly detection for univariate data, sorry, data time series only consider the relations between the current state and the previous state, that is the temporal dependency. But for a multivariate stream, both the temporal dependence and the correlation between the observation should be considered. That's why the added thickness multivariate time series data has now become a typical type of data for analyzing various behaviors created by combination of several variables. Now next coming to the non-stationarity. A time series is said to be stationary if its statistical properties do not change over time. Now what I mean by statistical property is coming to the mean and the variance. If over the time the mean and variance become constant, then we will call that it has the seasonality effect. This refers to a periodic and recurrent pattern caused by factors such as weather, holidays, marketing promotions, and the behavior of economic agents. In short, it is periodic fluctuations over a limited time scale. For example, power consumption is higher during the day and low during the night. Likewise, online sales increase rapidly over the Black Friday weekend and then the decrease. Similarly, we can compare that the univariate and multivariate also. Univariate, suppose you want to check the temperature of the next day based on the today's temperature. So you are having the two properties, that is the today's day and the with respect to that the temperature. So today is 30 degrees, so there is a high chance, and yesterday was 32 degrees, so there is a high chance between the tomorrow's will be temperature will be 33 or 32 or 30 like that. So based on the previous temperature, we are predicting that tomorrow's temperature. So only the factor is the time. Here the today, tomorrow, or yesterday. So this is the univariate. But when we are collectively saying the large number of, say, suppose you are considering that the Black Friday weekend, there is a decrease again. So Black Friday there will be having so many parameters, that is the sales of the product, the mood of the the customers and the discount of the sales price. So these are collectively are reflecting on the tomorrow's price, the price of the product. So the this are belongs to the seasonality. So concept drift, the non-stationarity of many real environment may lead to chance in the underlying statistical distribution of a data stream over time. The phenomenon goes by many names in literature, the most common of which is concept drift. This is the central issues, and because it can drill the performance of model learned from the historical data. So the change point in the manufacturing industry, the normal state of equipment often changes for several reasons. For instance, process conditions change as operations are stopped and restarted with a different settings. Noise. In many cases, noise is due to minor fluctuation in the sensor sensitivity and will have essentially no effect on the overall data. So that's the overall data structure. However, when the separations between noise and anomaly in a noise system is difficult, noise seriously affect the performance of detection model. In Python, we can use the autocorrelation plot to detect noise. So this they have introduced about the noise, about the properties of time series data. Now, when we are considering about the noise, automatically there are that terms autocorrelation and partial correlation also comes. So autocorrelation and partial correlation are the measure of the association between the current and the past series value, and it indicates which past series value are most useful in predicting the future value. With this knowledge, you can determine the order of the process in a ARIMA model, or more specifically. So autocorrelation at lag k, lag means behind the time we are considering. Suppose lag t means you are considering lag 1, you say one past value, lag 2, two past value. So like this lag k, this is the correlation between series values that are k interval apart. Partial autocorrelation function is the at the k. This is the correlation between series values that are k intervals apart according to the values of the interval between. So these are the things when we are considering the different models in time series, that ACA, PSA value helps to us to check the stationarity and other factor of time series. With this, we can find out the prediction, we do the classification, we can do the anomaly also. So these are the base of the anomaly detection to for in time series domain. So next is we will be discussing about the industrial use cases, not in much detail. So they have introduced some in the industrial application like smart manufacturing, smart energy management, cloud computing system, and structured health monitoring. So as we already discussed about the manufacturing management, cloud computing, we know that the cloud computing is the cloud that we where the third party is the storage thing we will discuss. That is used for in companies. The cloud computing is a very huge domain, and for industrial application it is used. So structure health monitoring also, the time series already I have discussed for our bed management and all, they have used the in time series. Next is the used model, that is so in this application like time series application, uh, so in this time series application, what are the models they have used? That they have used the GAN model, they have used the LSTM models. The GAN models is GAN is something there we are having two models. One is the generator, one is the discriminator. So the job of the generator is it is given to the algorithm real set of data. With this real set of data, they will be creating a no, the fake sample. Now it will give in to the fake sample to the generator, the real one and the fake one. Now the job of the fake one is that to check and sorry, the job of the discriminator is to distinguish between the real one or and fake one. So job of the generator is to make fool the discriminator, and discriminator job is to classify what is the real one. So like this game will continue, and the accuracy of the as much as the accuracy, the loss function will be created. That mean when acceleration of the generator will increase, and like this they will make something that their objective will be something to make the factual one would the fake one actually look like the real one. Then the LSTM for short-term dependency, it is done by the RNN. So for suppose there is I have an example now, filling the blanks, the color of the parrot is that. So for RNN, it is very easy to for short term basis, you can use that the color of the parrot is green. But if I have a sentence that I have 10 years expertise in most IT industry and dash dash that, and I have strong knowledge in dash. So if we are having the most time that blanks are there, so it is not short thing. So so for this it is very difficult for RNN to capture the actual result. So in that case, a memory unit is introduced in RNN. This single unit introduced the makes the decision by considering the current input and the previous output and the previous memory. We use that. So next we will have been discussing about the deep learning for anomaly detection. I request my fellow Ms. Access to explain about this. Thank you. Yes.
Resulting from kinds of approach. This deep learning techniques, the missions area, they are using some approach. Installing the solved approach. Pascal time, they are using time frequency domain analysis. This is thing, it's just done to apply frequency Fourier analysis for examine the data with frequency domain representation. So most of the time in time frequency domain analysis is used in signal processing analysis. They are using digital Fourier transform to express to represent the data as a frequency based. So still now not yet done on frequency domain data analysis, still now not yet done. So in practical, better than DFT or discrete Fourier transform, fast Fourier transform or FFT is better than discrete Fourier transform. So in practice, it's still now it's not done by Fourier frequency domain analysis, not done. So the second one is a statistical model. So to overcome with this approach in classical term, They are using mathematical analysis in time series data analysis, in time series data, because this statistical is just mathematically calculating means, like central tendency, mean, media, mode, and courtois or skewness. They are analyzing by that one, and based on that one, when they are doing variance, if the variance is more than the unexpected value, so it will be detected as anomaly. And the third one is distance-based model. In distance-based model, uh, in data analytics, they are saying in time series, converting this distance-based model just to a similarity index, just to check for similarity index. If the distance is very far, those two data or those two variables are not similar. So this similarity will be important for anomalies. Like if we are just converting to vectors all the words or maybe image converting to words to vectors, then calculating the distance most probably it's common to take Euclidean distance to calculate the distance between two points. So these 2 points in data in time series data, if these 2 points are more than like far distance, if they have far distance or if they have unexpected distance, it will detect as a anomaly. So in the fourth one, we are using predictive model. So in predictive model text description, so they are used in forecasting method of lots of forecasting models they are using. So in the past, like predictive is important for forecasting things. So they are based on the history of the data or based on the current data, we will forecast for the future. So it's important to classical approach when they are predictive time series data. So the fifth one in clustering model. In clustering model, in classical, they are doing for clustering is actually for unsupervised setting or supervised time series or any non-time series data also. So first we will map the data into a 2D or in multi-dimensional data plane. Then we will calculate the distance. If the distance is very near or small, those cluster will be considered as a one cluster. Or if the distance will be far, or those cluster will be considered as or second cluster. We are using like in clustering, they are using lots of model as timing we now. Like DBSCAN clustering is there, also Chemis, Chemidroid, and hierarchical model also there. Then when we are going for some challenging issues, these are two basic challenging issues in time series analysis. First one is lack of labels. Lack of labels means we are facing shortage of labeled data. Like this labeled data, maybe labeled data means like unclassified data. We maybe get there is no class on some data. So from this data, we will get a very big problem on when we are classifying this unlabeled data. So the second one is complexity of the data. If the data will be very complex, we cannot detect the anomalies. Like complexity is relative with dimensionality reduction. When we are reducing the data, because when the data is very complex, we have to reduce the data. So when we are reducing the data, we may lose some important points, or we may that important points may be discarded. So when we are discarding that important points, we may lose some accuracy. Our performance will be degraded. So complexity data is some big challenges in even if in now in this scenario even not even in classical also. So to overcome this solution from this challenge, we are using currently they are using deep learning approach for anomaly detection. So so this deep learning approach they use to develop like a model, deep learning based model by taking the following assumptions. Like the assumptions are semi-supervised the data will be semi-supervised or unsupervised data, and multivariate data and deep learning. So when we are considering semi-supervised data, the data will be unlabeled, almost unlabeled. Most of the data is considered as unlabeled, and on unsupervised data, all the data will be unlabeled. So you have to be learn the data for the upcoming test. So when we are unlabeling the data, for unlabeled data, it's very difficult to classify as which class they have to be appear. So this one will be deep learning will be have a great solution or have a great models to classify unsupervised model. If some unsupervision will be came, that data will be detected as a anomaly. So when we are considering, when we are assuming this multivariant is nothing, just it is a data set. The output will depending on MLT variables, depending on MLT variables. Like if you have data set x1, x2, x3 columns, our y will be depend on more than two variables. It's just multivariant. Or there is also bivariant. It's just depend on two variables. The output will be depend on two variables. There will be uh, a single variant, or the data will be output will be depend on single variables. So in multivariant data sets, the models should be capable of detecting those multivariables for extracting information and exploiting or preserving those information for our model learning. So deep learning brings very good methods to explore the data to handle the complex data and to extract information very easily. So that's why deep learning currently is very important scenario for this complexity of the data. So to analyze this one, to analyze these three methods, they are taking three perspectives. They are taking three perspectives. So first perspective is how they done intercorrelation between variables. So studying intercorrelation between variables means just studying the pattern. So we will say one by one about these three topics, and the second one will be how they model temporal context information. Temporal context information means just for some period of time, our information context will be changed time by time. So how we model this temporal context information. The third one is how they done anomaly score or thresholds. How we are going. This is the threshold or this is the anomaly score. Like for example, when we are living in a room, uh, we are making our weather condition or temperature. We are making our temperature 25. If more than 40, maybe it's anomaly, or less than 10, maybe it's anomaly. How this 40 like upper limits and upper control, and how will be 10 is a lower control. How will be taking that number, or that number may be changing uh, time to time. Like when we are taking this number is anomaly for this time, or in another time this number may not be anomaly. So how we are taking this thing, let's see. So in this scenario, just intercorrelation between variables. Studying intercorrelation between variables is a very important thing, because we have to study the pattern. We have to study the pattern or intercorrelation between these two. If the variables are two, studying intercorrelation between the variables are very important to study the pattern. So dimensionality reduction is a very important thing. Our dimension may be like we may have a data set of 100 by 100 or 1000 by 1000. So our pattern will be very vast and very high. So we should be reduce our dimensions. So when we are reducing our dimension, we may lose a lot of important information. So typically, that a linear algebra we are using like PCA and SVD we are using for dimensionality reduction. And when we are coming to deep learning, we are using neural network based dimensionality reduction, like such as like autoencoder or vector autoencoder. We are using those to reduce the dimensions. So when we are doing when we are reducing the dimension, it will be easy for learning and testing also. so we can be easily detect anomaly at that time. When we are talking about second point, 2D matrix. So the matrix will be 2D. It's very robust. If you are doing 2D matrix analysis, it's very simple to robust to use 2D matrix in multivariant analysis. And second one, third one is graph. It's very high powerful deep learning tools is graph neural network. So graph neural network is just they are detecting it may be message or any time series data. So detecting all those things using node and edge. Let's say if these 2 points have point 1 and point 2 have a relationship together, or they are sharing some common things together, they will connect it by edge. So that thing will be detected if they don't have any relationship. If some nodes don't have any relationship with any nodes, that node will be detected as a anomaly. So graph is a very big tools to analyze time series and time series data. When we are talking about which model should be used for temporal context, so knowledge about the behavior and can suggest future shifts. So these four models we are talking as example, or they are taking on the paper: recurrent neural network, convolutional neural network, and hybrid. And attentions they are taking as a model for temporal context. So when we are talking recurrent neural network is just it's composed of long short-term memory (LSTM) and gate gate recurrent unit. So that gate recurrent unit is abbreviated as GRU. So RNN is nothing, just composed of LSTM and GRU. So LSTM is just long short term memory. So that thing is just have a lots of nodes like input node, output node, forgetting gates, remembering like saving gates. Those things are very important in RNN topics. So these things are addressed uh, a vanishing gradient problem, vanishing gradient problem in neural network. So if our gradient problem is too small, or if our gradient problem is too high, we have to be uh, we have to be switch a parameter that will be fit for our data, because when we are changing, when specifically talking, when we are changing the weight value, we are taking LSTM or we are taking GNU. So it's very important thing for anomalies at that time. So when we are talking about convolutional neural network, it's better than recurrent neural network, because they are using feature extraction in sequence, and to learn a pattern is very important, better than RNN, because in convolutional neural network there is a way that can change every weight in uh, in backward way also. So it's better than RNN. And when we are talking about hybrid is just nothing. It's composed of convolutional neural network and LSTM. So there is one hybrid model named as conv LSTM. Conv LSTM is just a combination of convolutional neural network and long short term memory. So this LSTM is very important, and when we are merging with convolutional neural network, it's very getting very high performance of error. So when we are talking about attention is nothing, just used to an algorithm to reduce the errors, such as like most of the time attention are using on language area. So in language area, used for NLP, used for transformation and bidirectional, like BERT is very important for BERT and uh, transformation learning. So in anomaly criteria, what criteria should be take when we are when we are deciding this data point are anomaly, or this pattern are anomaly, or this context are anomaly. So number of diagnostic results we should take that I said before, anomaly score. We will put some threshold. Those the points or those analysis is above that threshold or below that threshold, that will be detected as an anomaly. So we have to reconstruct the errors. So we have to reconstruct the error means for, let's say, when we are doing backward propagation in when we are doing one iteration, our error may be big. When we are doing second, we will reconstruct the weight value and we will reduce the error. And we will do third iteration, we will reduce the error. So reconstructing the model will be reduce the error. Then prediction error. Prediction error means just we will get some uh, threshold or acceptance threshold. Plus or minus this point will be uh, acceptable on let's say that hypothesis analysis. We can accept if our error will be between these things. So if our error will be more than these things, we will not be tolerable. Like a tolerance, prediction error will be as a tolerance, can take as a tolerance. So if more than that tolerance or less than that tolerance, we will not be take as a normal data point. We will take as an anomaly. Third one is dissimilarity. Dissimilarity is just nothing. We will just take in similarity. We will just take distance metrics. For example, we will calculate the distance between these 2 points. If the distance will be very high, those points are dissimilar. So we will detect with another point also. If that point will be dissimilar, those things will be an anomaly. We will not detect as a normal. Like we can compare with any point with the origin. If it's far from the origin, it will take us a dissimilar or anomaly. So when we are selecting the model, the majority of existing anomaly detection techniques are heavily tailored to specific use case. So to specific use case, our existing anomaly detection is very high. So there is no one size fits in all approach. There is no one size fits like such as this means something we are saying anomaly on this place may not be anomaly in other place. Like I said, uh, suddenly when we are using AC, if AC will be become zero, it may not be anomaly when it's in winter time. It's winter time, we didn't open AC. So time to time, it may not be like time-based anomaly there one. So there is no one fit size or one size fit anomaly at all. It mean that we are considering anomaly now, maybe may not be anomaly in another place. So they provide guidelines for model selection. This paper, those researchers, they provide guidelines for model selection according to purpose and circumstance of each application. And training techniques should be considered as detection strategies and training and propagation or pre-processing techniques. So when we are doing this real-time versus early warning, there is two types of detections. Real-time versus warning detections. Real-time detections is most of the time when we are getting these real-time detections, or when we are doing online detections. Online detections means streaming detection. When we are detecting anomaly for streaming data, that is called real-time detection. And when we are when we are doing prediction, that will be early warning anomaly. Like let's say earthquake is one of anomaly things, as we know. So predicting earthquake before 1 year or before 1 month is also known as early warning anomaly detections. Based on the data, based on the history of the data or current data, we will detect what anomalies we should face for the future. That's called early warning anomalies. Sliding window versus incremental update. Sliding window means we are taking a mini batch of anomalies. Mini batch means if you have 10,000 data, and we will divide the data into 1,000, 1,000, 1,000, and we will detect anomalies for each windows. So previously, my classmates Neha presented like one types of anomalies we cannot be detect easily because some places we may not be get in any anomalies. So in sliding window, we may not get a very big anomalies because we are doing sliding window. We are separating the data into some points, then detecting anomalies based on only on that windows. Incremental update means for uh, updates will be coming in very high rate. So when updates will be coming in very high rate, we have to detect on the speed of that data rate. So we will take observations on on those data rates. So those data rate must be our model must be following on those data rates. So that's called incremental data rates. Then the other topic is training versus pre-processing techniques. So before we are doing training, as we know, we have to do a pre-processing. So we have to refine our data before doing training. So if we are not refining the data, our training loss will be very high, and our testing loss also very high, because like we may get some empty data or empty column, or we may get some anomalies like before we are taking to training. So we have to decide our loss function, which should be in our loss function. That advertisal, for example, advertiser loss is before we are doing some uh, techniques, some application of training techniques. We have to get them the, the losses before we are doing some uh, calculations. We have to get we may get some loss, so we have to take those advertiser loss. And second, we'll get we have to do reconstruction loss. Reconstruction loss means, let's say in time series in convolutional neural network, we will reconstruct our weight value. We will change, we will update our loss to our weight value to reconstruct, to reduce the reconstruction of loss. So we will reconstruct our model to reduce the loss. Then the prediction loss. Prediction loss is just before we are getting the anomaly, we will predict our loss. So we are that's prediction loss. And negative log likelihood, just some likelihood similarities between some data sets. We have to do if that negative likelihood means those likelihoods are not similar, so we have to calculate negative likelihood calculations before we are training the data. This is just pre-processing techniques. Then the other one is batch processing and online update. So batch processing, as I told you before, batch processing is just taking batch by batch, taking the data batch by batch and training it, and finding the average of those data and calculating the error. That means batch processing. And when we are doing online update is nothing only for streaming data, non-stopping streaming data. When non-stopping streaming data is coming, we have to do online update for our model. So the other topics is denoising. Denoising means just removing the noise by making some smoothing techniques, or by making some transformational learning, and by making some estimation of the data. Just smoothing is nothing. It's just by reducing uh, some spikes of data, like some data will be out of the range, like outliers, or some data may not be considered as outlier, or may not be considered as a normal data. So that must be doing for smoothing, like uh, some unstationarity maybe will face. So those unstationarity means just stochastic. So those stochastic must be smooth, or data must be smooth before we are doing any training. So that making smoothing means just denoising or removing noise on that data. And when come to conclusion, they're identifying and they identify and troubleshoot unexpected events from time series data, can help prevent accidents. Like it's very predicting before it's just protecting or preventing accidents, and will get a financial loss, will reduce our financial loss. So using time series data to identify and fix unexpected events can help to avoid our accident or any financial loss. So depending on these deep learning based techniques, have gotten a lot of attention recently due to their expectational capacity to tackle these difficulties. So they described various applications of anomaly detection in several industries. So they provide a review on this paper. They provide a review on the latest deep learning based anomaly detection method for time series data. So they finish or they conclude their guidelines for model selection in technical training techniques. So my fellow mates, Neha can present. Uh, this is the reference. She can present uh, some implementation we do. So she will present that implementation. Thank you.
Thank you, Asrich. Now I'm going to represent some implementation on time series data that which my fellow mates Asrich explain about AR model, MA model, ARIMA model, and the anomaly detection part. So here I have having some issue, that is some code that on prediction with AI model. So an auto regression model makes an assumption that observation at previous time steps are usual to predict the value at the next time step. So auto regression, that is the AR model, always consider that the previous value and based on that the next value is concluded. So the meaning with the AR1, there are different classification of different type of auto regression model, that AR1, AR2, and AR model types. So based on the how many past value you are considering for that uh, to predict the next value. That based on that we are giving the name year 1, year 2. Year 1 for that one past value, year 2 is for next with the past two values are predicting for the next one, like this. So minimal daily temperature, we have taken the data set. This data set describes the minimum daily temperature over 10 years in the city Melbourne, Australia. The units are degrees Celsius and there are 3,650 observations. This source of the data is credited as the Australian Bureau of Meteorology. So the libraries we have included from pandas, input read, CSV, matplot, LIB, import pyplot. For the graph plotting we need these libraries. So series read, CSV, we read the data file, that CSV file, minimum temperature.csv with the head showing the header is 0 and index column is 0. So index is starting from the 0 to 1. So next is to print the series head. So we are printing the first 5 values, the top 5 values, and show the plot. So this is the temperature with respect to the date and time date. So it's a univariate time series we have taken. Then like we check the auto correlation. We can plot the observation at the previous time step. Ashish, please mute. It's echo. So we can plot the observation at the previous time step t minus 1 with the observation at the next in the time step t plus 1 as a scatter plot. So from pandas plotting the input lag plot series. So pie plot show where we are having the plot. Not now we can create a lag version one of the minimum daily temperature dataset and calculate the correlation metric of each column with other columns including the itself. So here we are having that t minus 1 and t plus 1 as the column vector, and we are having the data frame with that concentration factor. And then the auto regression model we have created. An auto regression model is a linear regression model that use the lag variable as an input variable. We'll use the stat models library which provides an auto regression model where you must specify an appropriate lag value and trains a linear regression model. It's provided in the auto reg classes. We can use this modify. Then the stats model is used, and for that we for the upgrade the stats model. and then create and evaluate a statistic auto-regressive model for the pipeline model. That is from the stats model, we import the auto-regression, and then for scalar matrix, import the mean square root error, that is MAC error we have to use. Then I want to import the square root function, and then I want to read the again the temperature CSV and the series with the header index column and parse date is true, because we are not changing that parse date with that day, month and year column. We are just see it at a glance. So split the data set to check the auto regression, that is the seasonality. So split the data set series, the value. So first we check the interpret the values from the series dot values, and then we divide it the train and test data set. So last 7 value will be considered as the test, and the remaining one is the train. So train auto regression, the model auto regression train the left with 29 and the fit the model. So if the coefficients are getting it, then we make the prediction, and the predicted values are, so there is a, we are having the predicted value and the expected value. We plot the result and we'll be getting with that our actual prediction is the blue line and the predicted one is the red line. So this about the this AR model. Now we're coming to the ARIMA model. Just take a second. So the prediction with the ARIMA model, it's similarly import the library function, then they improve the upgrade the in stats model. Then from that scroll up, we are having the air passengers data set, where air passenger data set will be being with the month with the number of passengers they are having. That's the air, many number of passengers are traveling. So with month wise, we are having the data. Then we are checking the stationarity. So we have explained in that is the properties of time series. So we can check the trace stationarity in by few methods, that is by checking overall just visualization, by checking the graph, or by checking the global value, and that is the we will divide it into segments, and we'll check the overall segment. They check the mean values of the segment wise part and the overall part. If they are same, then we'll consider this is the mean value, mean and variance in constant, and it will be the stationary, and otherwise it implemented decoupled at states. So stationarity here we are dividing the value into two parts and split it. So we can say the two parts, the mean and variance value are different. So it's not like stationarity. So now we are having the ADF test. They are the augmented decoupled test, where we will be having if the static p value is less than 0.05, so we will be having that it is the stationary, but we are having the value is p value is 0.99. So we have to make it stationary, and we will, for that we will apply the differencing operation. So difference this data as a dfd dot values, and for I mates we will be having the difference of the previous one, and then we will plot it. So and after differencing, the plot is like that, and then we'll having the ADF test, and we'll be getting the value. P value is 0.5, critical value is 1% is minus 3.4, and 10% is minus 2.579. So the as per the our statistic hypothesis, the test statistic is less than critical value 10%. So data is 90% purely stationary. Then we are having the model of the static where the ARIMA model we are using, and the model fit with that. Then we will be having the plot of the prediction air passengers, and the model fit will be having the MAC value, the mean square value. Mean square value is 1042. So it's not that much accurate result we will be getting. So that's why we plotted the auto-relation and partial correlation. We will be having that after one leg there, after two uh, minus zero point 0.5, there is the lagging is not that much okay. So this is about the prediction model of the ARIMA model, and then we'll having an anomaly detection of the example. On anomaly detection, that is a predict data set for time series forecasting with this the anomaly detection using the LSTM. Already we and my colleagues explained about the LSTM. So long-term, short-term memory is that the recurrent neural network having vanishing gradient problem, long short-term memory network capable of the learning long-term dependency using cell memory unit, and LSTM has three gates to control the cell data. So we are having the data file with the maximum very dense activation and dropout at that layers recurrent. We are having the LSTM installed LSTM and the LSTM model one will be having the data that is the hours is the time start with the anomaly of 0. So standard size of size we are having the hours, the mean max and we are changing the value hours daylight into 0, 1, 2, 3, 4, 5 in the for the pre-processing of the data. Then plot the data. We are having this type of data certainly. So time series lag scatter plot we are having that this the time series modeling assume the relationship. So the series is 134 for lag version. This series is like that lag 2. So it will always take the past one. So this is the we are plotting the lag value or the lag version of 2. Then prepare the dataset for time series forecasting, train set, input train and output train, and test data set is input test and output test. Data set shape is 7267 with the 6 columns. Important parameters, that prediction time is 1, test data size is 1000 and unroll length is 50. So test test data size and train the data on the prediction, and then we test the data with the test prediction value. So data head is 0 point like this, and the print the train value and the test value. And the size of the train and test data, there is a train x and y train do it divide into 6215 and y is at 1050. So window size is 50 and we'll be having the windows shape of the data LSTM model. We are sequencing and compile the model with LSTM with 2 epoch, and we are having that this is the anomaly we'll be having with, if we predict with the anomaly we'll be having this anomaly. Thank you. So these are about the anomaly detection using LSTM. So like with this we want to conclude our presentation. Thank you.